Hi, everyone. I'm Zack Kass, Global AI Advisor and former head of go-to-market at OpenAI. And today I'm so excited to be hanging out with Vamsi Popana, the SVP of AI at AMD. Vamsi, it's great to be here.
Thank you, Zach. It's a huge pleasure to be here, and I'm looking forward to chatting with you.
Likewise. And of course, somehow in a fun twist of fate, I find myself today in India, of all places, where you did your studies and you're back home. But thanks in large part to technology, we're able to communicate at a rapid pace in real time. What we need to plan to cover today, at the very least, is hardware architecture, acceleration in open source and frontier in AI innovation, and of course, the big one, which is what's next for developers. And I can tell you now, having sort of stared at this for the last 3 years, it's never been more exciting for developers, but you know this better than anyone.
Yeah, no, it's a great set of topics. It's an amazing time for AI, right? Literally as we sit here, the future of computing is being reshaped. It's an exciting time for hardware developers. It's been said that it's like the golden age of computer architecture by Hennessy and Patterson. But also for developers, right? You are fundamentally getting access to compute that you've never seen in your lives, right? So super exciting.
There are a lot of things that cross your plate every day, and the things that you have to now consider come so fast and furious that I can't possibly imagine how you keep up with all of it. But let's start with the basics, which is, can you just talk to us right now about where compute, first of all, where is compute today? How do you describe where it is today? And then I'll ask the harder question, which is, where is this going?
Yeah. Look, I grew up, as you said, like in India, right? I went to school at the IIT, did computer science, studied architecture, and I got a PhD in computer engineering. And so I feel like I have seen the evolution of compute at least through my career, and for call it, I don't know, 5, 6, 7 decades, right? We have done compute in a certain way. It's the traditional von Neumann architectures, right? And you fetch something from memory, you process it, you write it back into memory, and it's been that style and form of computing. And of course, right, we've had phenomenal gains over all this period. Architecture, but also technology, right? We've really had the amazing ride on the technology curve. In my own career, we have gone from, I don't know, 0.35 micron to now we are like doing 2 nanometers, right? So I don't know how many ever sort of orders of magnitude that is.
Yeah,
It's
many.
incredible. Many orders of magnitude of improvement. And, Fmaxes went from, I've seen chips at 10, 20, 30 megahertz to, we went to hundreds of megahertz to gigahertz. And, at some point,
And critically, we brought the cost down on all that too, right? I mean,
that's right.
that's the other remarkable thing that's going on.
It's just amazing, the things that have happened. But as much progress as we have made, you could argue that there is a fundamentally different way of doing compute that we have found and are now starting to think about very, very differently. In my mind, right, in my humble opinion, it's rooted in a few things. The first is, the world is insanely parallel, right? If you think about like when you process an image, right, you're not reading a pixel at a time. You're actually, looking at an image and processing all of that information in parallel, right? You have all these capabilities biologically in nature that allows you to process things in parallel.
Well, some of us, I admit, I struggle to even context switch between simple tasks, but yes, your point is well taken.
That's right. No, you're being incredibly humble, Zach. But yeah, the world is insanely parallel, and there have been various computer architecture innovations that have created parallel machines, and we are seeing those kinds of innovations really, really come to fruition in this time. It's also true that you don't need to process things exactly. There's a lot of room for inexact or imprecise processing. For example, you don't need 64 bits to process, lots of data. You can do just well with 4 bits or 8 bits or even lower. So if you combine all of that you have a very, very different way of thinking about compute, where you can take in a lot of parallel information, process all of that, simultaneously in an imprecise fashion, and actually get useful work done.